Okay, here we go. So I'm actually recording this the night before. Um, I got to do PSAT today with 10th graders, so therefore you're just going to get a video class. And plus, it's just a review of Chapter 11 stuff. So here we go. All right, if it's not on this review, it is not on the test. And we're going to do 2 days of this. So one day, just you by yourself with this, watching this video. No chance to ask questions unless you send me a chat. And then the day after, well, I guess tomorrow, then we'll do a second one and it will be live. So if you have any questions, show up for that one. All right, so here we go. So the entire chapter was on basically simplifying square roots, adding them, subtracting them, multiplying, dividing them, and Pythagorean theorem. That's what the test is going to be on. Now, I think there's like 30 of these. I'll do a handful of each particular section. I'll leave a bunch of them left for you to do by yourself so that you can get confident that you're doing it right, or you can ask questions. My suggestion is on your resource card on one side of it, just have all the perfect squares written down. You don't need one, but remember two squared is 4. Remember, these are your PS, perfect squares. And the square root of 4 is, so these are the square roots, SR, perfect squares and square roots. So 2 squared is 4, square root of 4 is 2. So 3 squared is 9, the square root of 9 is 3. 4 squared is 16, the square root of 16 is 4. 5 squared is 25, the square root of 25 is 5. 6 squared, 36. Square root of 36 is 6. 7 squared, 49. You can kind of see what we're doing here. And this should already be in your notes. 8 squared, 64. 9 squared, 81. Hopefully you have these memorized. 10 squared, you better have that one memorized. 100. 11 squared, 121. Now you're going to encounter some numbers that are bigger than the first 16, but they will be easier ones. It's 144. So for instance, I don't know, 420 times 20, but it would be obvious. Let's see, 13 squared, that's your 169. And then there's that little pattern of the next one, 14 squared is just those numbers flip-flopped around, 196. 15 squared, 225. And then the last one, or at least the one that I said you need to have memorized, 256. Now, do you really need to have these memorized? No, but you need to be able to make this chart right here. I'm going to box around it. See in blue. So these are your perfect squares. And remember, when we simplify a square root or a radical, what we're looking for is to rewrite the number that's underneath the square root symbol as one of these numbers in the blue box times any other number other than 1. 1 doesn't really get us anywhere. All right, let's see how this works. So we got the square root of 160. Notice 160 is not on the list. So I'm going to pick the largest number that goes into 160 even, and I'm kind of at a loss here. Maybe it's a larger number, but I'm thinking 4. So the square root of 160, I know 4 goes in there. 4 times 40. I know there's a bigger number, but I just can't, figure it out off the top of my head. So we'll just do this multiple times. Remember, there's now a perfect square underneath here, so that's the square root of 4 times the square root of 40. Square root of 4 is 2. So we get 2 root 40. And then, like I said, you can see that there's a 4 in 40 now. So we're just doing it in multiple steps, 4 times 10. So it turned out that 16, oh yeah, 16 times 10. What am I thinking? How come I couldn't figure that one out? Ooh, because there's even a bigger one. Sorry, I wrote 20, I meant 10. 4 times 10. And the square root of 4 again is 2, and 2 times 2. Not 2 times 4, because when you take the square root of 4, you get 2, so it's 2 times 2, and you get 4 root 10. Now, I did that pretty quickly. This is not our first rodeo. We've done this a bunch, right? You should be comfortable with that. By the way, if you had figured out right from the very start, how come I didn't see that? 16 times 10, the square root of 16 comes outside. Square root of 16 is 4, so 4 root 10. One other explanation, in case you were paying absolutely no attention. Once you rewrite 160 as 16 times 10, you could rewrite that as the square root of 16 times the square root of 10. And the square root of 16 is 4, so that's 4 times the square root of 10. We just would rather write it as 4 root 10. There you go. There's 3 explanations. As I said, I'm not going to do them all. I'll leave plenty of them for you to work with, but we'll do a bunch of them. I'll give you 33 of them. Let's see, what's another one that looks good? 216. 216 isn't on the test. Once again, 4 is my friendly, if it's an even number and it's large and I can't recognize it, 4 probably goes into it. 4 does go into it. By the way, the rule of 4s, if you're curious and can't remember, is that if 4 goes into the last 2 digits, then it goes into the whole darn thing. So I guarantee you 4 isn't the large. I don't know, maybe it is. Let's see. Let's do this one. Let's see, that would be 4 times 4 goes into 21, 5 times 1 left over, so 54. Oh yeah, 9 does. Okay. Let's take the square root of 4 is 2, so we got it 2 root 54. And I know 9 goes into 54, so 2 times the square root of what? 9 times 6. Yeah, there we go. Square root of 9 is 3. 3 times 2 is 6, so we get 6 root 6. 9 times 4 is 36. So it turns out that 36 goes into 216. I mean, who would have known that one off the top of your head? Now, granted, with a calculator, I can do that really quickly. So with a calculator, you'd take 216 divided by 4, it would work. Divided by 9 wouldn't work. Divided by 16, it would work. And that's the last one that would work. I'm sorry, not 16, 36. It's late in the day while I'm doing this video. Okay. Do we want to do any more of these? Let's see. That one's easy. That one's easy. That one's easy. All right. So first one right here. Notice we have a coefficient now. Coefficient meaning there is a number on the outside. So let's see. We got to do 147. Now notice 147, the last digit is odd. So our friend number 4, well, number 4 certainly isn't going to work. Does 9 go into it? Nope. 16, you can't, we're not going to consider any of the even numbers because remember, an even number times an even number is even, and even an even number times an odd number is even. So the only one you're going to consider now are the odd ones. So 9, does 9 go into 147? Nope. 25? Nope. So 49 is our first candidate, and it turns out that 49 times, why did I write 43? 49 times 3. 3 times 9, 27, carry your 2. 3 times 4 is 12, plus 2 is 14. Yeah, that works. But remember, there's that 7 right there that's still on the outside. I wish they would have made that an 8 or something like that. All right, so the square root of 49 is 7. I'm not saying that the 7 on the outside is the answer, but this, okay, here's the long explanation. This would be the square root of 49 times the square root of 3. And 7 stays 7. The square root of 49 is another 7 times the square root of 3. 7 times 7 is 49. So we get 49 root 3. There's your long explanation. Most of you would probably go from that step down to there, and that's fine. Just want to make sure, like I said, I wish that number wasn't a 7. It leaves you the impression that the reason why it's a 7 because of the square root of 4. It's not. It just happens to be a 7. All right. As always, if I'm doing this, I'm just recording it, and I'm getting no feedback from you guys. You're not able to ask questions in the moment. Certainly not the best way of doing things. Yeah, let's do this one. All right. Okay, let's see. 9 root 245. 9 root 245. Trying to think out loud here. Nothing's coming into my mind. Let's see. 9 times, well, it's odd once again. 25 doesn't go into 45. 9. Remember, the rule of 9 is you add up all the digits and see if 9 goes into it. 2 plus 4 is 6, plus 5 is 11. 9 doesn't go into it. 25 doesn't. Does 49? 49. 49. I got to do a little bit of scratch work here. Times 5. Does that work? 45 here. Yeah, that works. It's 49 times 5. What do you know? 49 again. This process of trying to figure out what number goes into it, one, it's a little bit of knowledge of the numbers, and two, it's no joke, it's work, right? You actually got to do some scratch work to figure this one out. All right, so let's see. The square root of 49 is 7, and 7 times 9 is 63. So we get 63 root 5. There you go. That wasn't too bad. I keep wanting to say, questions, anyone? Well, there's nobody live right now except for me, so nobody can ask me questions. All right, 225, notice, is on the list. I'll just do this one simply because it's on the list. Notice the square root of 225 is 15, so this is simply 10 times the square root of 225 is 15. So it's just 10 times 15, which is 150. All right, that one wasn't bad at all. Oops, put the circle around the 1. We don't want to clear everything. All right, do I want to do any more for you? Okay, so I'm going to stop it right there. So the first 10 questions are just simplify a square root. Now here's the deal. It turns out that the rest of the math that we're going to be doing right here, you're also going to be simplifying square roots. So it's like I'm getting a twofer here, meaning that I'm also going to be evaluating on this every single section here. So the very next section is going to be on multiplying square roots. In other words, you're going to have two terms that we need to multiply together. So, we need to multiply. I'm not sure why I was not drawing this one times this one. So I know Kaylee knows the rule, and the rule is outsides with outsides, insides with insides. So if we do outsides with outsides, -5 times -4 is a positive 20. And if we do insides with insides, 5 times 5 is 25. So we get 20 root 25. And this is what I mean by every single question that's going to be like the first 10 eventually. So now we have to simplify this. Well, luckily for us, 25 is a perfect square. Square root of 25 is 5. 5 times 20 is 100. That's crazy, right? Who would have thought that the answer was 100? Just checking. Yeah, look at that. It's 100. What do you know? Sometimes you just got to check things just to make sure you're doing them right. By the way, as always, the answers are on the back. And make sure you're checking your answers. All right, let's do something a bit more interesting. Okay, this one's slightly more interesting, not very, slightly more interesting. Okay, so let's see. Notice there's no coefficient in front of the first term, but remember there's always a 1 there. So when we do outsides with outsides, inside with insides, the outside 1 times 3 is still 3, and the inside 2 times 2 is 4. Square root of 4 is 2. 2 times 3 is 6. Look at that. Now, will I ever give you one where the insides are not the same number? Oh, yes. Oh, yes, I will. All right, maybe we should jump to one of those. All right, let's see. Here we go. First one. All right, number 16. Once again, the first term doesn't have a coefficient, so I put a 1 there. Outsides with outsides, insides with insides. So 1 times 3 is 3. That's the outside. The inside, let's see, 2 times 8 is, oh, look at us. It gave us a perfect square. 16, the square root of 16 is 4. 4 times 3 is 12. Well, we're just zooming along here. All right, let's find the hardest one here for multiplication. Multiplication is not that bad. That was the last one for multiplication. All right. Let's look at some of the division ones. Now, division is the first time that we actually have issues. Remember the 3 rules. All right. I need to put a line down here. All right. The 3 rules. I don't need that much space, but the 3 rules is number 1, no perfect squares inside. No perfect squares inside. Meaning that if you are claiming that you have the answer, you cannot have any perfect squares underneath the radical. Under radical. How about that? Under radical. So the square root symbol, look at it, make sure underneath it there are no perfect, I left off the word squares. What do you know? No perfect squares under radical. So that was rule 1. And that was the rule that we were following for everyone up to now, under radical. All right, number 2, no fractions. No fractions underneath radical. under radical. I left off the word under on this one as well too. Under radical, under radical. And the last rule, where we're about to use it, and that is denominator, no square roots. Denominator, denom, I'll just leave it as denom, no square roots. Those are the three rules that we have to follow, square roots. Okay. Now we're just talking about the final answer. Obviously, right now I got a square root in the denominator. I got fractions. There are no perfect squares underneath it. Okay, so how do you handle this one? So we look underneath each square root symbol first, see if there's any fractions. Nope. See if there's any perfect squares. Nope. So the only problem is number 3 here. I've got square root in the denominator. When you have a square root in the denominator, you simply take the fraction and multiply the top and the bottom by the thing you need to get rid of. I need to get rid of that square root, not 4. 4 is perfectly fine, but I need to get rid of that square root of 3. So we multiply both the numerator and the denominator by the square root of 3. The thing that's given us a problem, and watch the magic. Well, insides with insides, outsides with outsides. There's going to be nothing on the outside most of the time here. 5 times 3 is 15, so I get the square root of 15 in the numerator, and the denominator I get 4 root 9. All right, looks like we're done, but wait a minute, I got to take the square root of 9. The square root of 9 is 3, and 3 times 4 is 12. There are no perfect squares inside of 15. So that's my final answer. At least that's what I'm claiming. And notice that matches the real answer. I should do this in a different color. Too late. Okay. So all of the division ones, we will have to use all 3 rules. For the multiplication ones and for the simplifying runs, we're just basically following rule 1 and rule 2. All right, let's do one that's a bit more interesting. Okay, maybe. All right, that one looks pretty interesting. Okay, let's do that one, 21. There's no fractions. And you're like, yeah, there is. There's one big, yeah, but I'm saying that I'm thinking about this, 4 over 7. There's a square root underneath a fraction, all right? If that's the case, then you break it up into the square root of 4 over the square root of 7. So notice maybe that was the previous step, but it's already been done for us. Our issue here is that there are some perfect squares underneath the square root symbol. Notice there's a 4, and inside of 20, there's also another 4. Well, the square root of 4 is 2. And the bottom one could be written as 3 times the square root of 4 times 5. All right, square root of 4 is 2. 2 times 3 is 6. So we get 2 over 6 root 5. Oh, this one's going to be a lot of work. Let's see, I'll use blue here. Let's see, I can reduce the fraction. The 2 would turn into 1, and the 6 would turn into a 3. I'm just dividing top and bottom by 2. So let's see, 1's left on the top because 2 divided by 2 is 1. On the bottom, I have 3 root 5, and it feels like we're done. But we got that silly root 5 there, and that's rule 3. We can't have any square roots in the denominator, so we got to multiply top and bottom, not by 3 root 5, just by root 5. That's the number I need to get rid of. If that one's gone, then life is good here. So let's see, 1 times the square root of 5 is the square root of 5 in the numerator. And the denominator would be 3 root 25. Some of you were screaming at your screen right now saying, why would you do that? Square root of 5 times the square root of 5 is 5, and 5 times 3 is 15. Okay, you got me. You can skip that step and write that. So it's square root of 5 over 15. For those of you that were confused by that comment, well, ignore it. Just do exactly what I did. Square root of 25 is 5. 5 times 3 is 15. There we go. So square root of 5 over 15. Notice I am checking my answers to make sure I'm doing it correctly. A lot of math there. You can easily make a mistake. I think that might have been the most complicated one for the division. Let's see. That one's not too bad. Yeah. I'm going to leave the rest of them there for you to play with. That one right there as well. Notice I can take a 4 out of that 8, right? Square root of 4 times 2. But I'll let you play with that one. Okay, so what's next? So we just did, oh yeah, addition, subtraction. Okay, so the rule for addition, subtraction is that you can only, I need another thing, you can only add or subtract when what's underneath the square root is exactly, plus or minus, is exactly the same. So if you have the square root of whatever, the other one better say the same whatever. And by whatever, I mean this right there. It looks like a fraction now, so let me not do that. So as long as you have underneath the radical exactly the same number, you can add or subtract them. Notice I don't. I got a 54 and a 6, not the same number. So we're back to rule 1, 2, 3. See if we can do something. No perfect squares in 6, but 54, I think there's a 9, right? 9 times 6, right? So that would be what, 9 times 6. And yes, you could skip this step and go right to what the simplified version is. So I'm just showing you all the steps. Square root of 9 is 3. 3 times negative 2 is negative 6. So I get negative 6. That's a lot of sixes here. Root 6 plus 2 root 6. And now notice, different color. Notice I have exactly the same underneath the radical. So I can add or subtract these. To add or subtract them, you don't change the square root of 6. You look at the coefficients, this number right here. Let me do that in green. This number right here, and to that you will either add or subtract that number right there. Maybe green wasn't a good choice. Doesn't really stand out. So negative 6 plus 2 is negative 4. So I get negative 4. Square root of 6 stays the square root of 6. There you go. I guess I should put equal signs here, shouldn't I? Okay. It seems like I'm going fast. I am, because like I said, there's nobody here to slow me down and ask questions. But trust me when I say, when we go over this again, and we will do this again. Let's see, tomorrow's Wednesday. So when we do this on Thursday, and you show up live for class, you can ask as many questions. We'll go as fast or as slow as you want. All right, where are we at? That one looks boring. That one, is there one where I have to do something to both? Oh, by the way, this one right here, notice I already have the same thing underneath. You just add or subtract. So let's see, negative 3 minus 2 is negative 5. So you just get negative 5 root 5. That one's nice and easy. I did not give you one where both of them had to be reduced. All right, let's try this one. Well, can't do anything with the 5, but I can with the 20. So let's see, negative 2 root 5 minus, there's a 4 that I can pull out of 20. So 4 times 5. So that would be negative 2 root 5 minus the square root of 4 is 2. So 2 root 5. Ooh, look, we got the same thing. That's not 0. That says negative 2 minus 2. That's not 0. That's negative 4 root 5. Remember, same signs, add. Equal, 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 done. Yay, us. Well, you can't see it, but it says negative 4 root 5. All right. So let's see, we did simplifying, we did multiplying, we did dividing. No, we didn't. Yeah, we did dividing. Now we just did adding, subtracting. What's left is Pythagorean theorem. All right, so Pythagorean theorem, I'm kind of out of space here on my resource card. Let's see, can I squeeze it in? Sure. If you have a right triangle with legs A and leg B, that the square of A and B added together, that's the sum of their squares, is equal to the square of the hypotenuse. The hypotenuse is always the side, in blue here, is always the side that is opposite the right angle. Is always the side that is opposite the right angle. All right, I feel like writing in blue now, so I'm gonna write in blue. So 11 is your C, and this is your A value, and this is your B value. A and B doesn't matter. You can flip-flop those. I'll use X, though. All right, so let's see, A squared, but we're calling that X. So X squared plus B squared, that would be 4 squared. Some of you were screaming, why don't you just write 16? Yes, you could do that. Is equal to 11 squared. And yes, you could write 121 right from the start. So let me catch up with you, smarty pants. So that's what, plus 16 equals 121. Notice I can still use my resource card, 11 squared, 121. Now we just do a little bit of algebra, subtract 16 from both sides. Can we do that in our head? Let's see, 10 minus 121 would be 111 minus another 6, 105. So I get the square root of 105. Or, the next step, how do you get rid of square root? Squaring, you take the square root of both sides. We're not going to get a plus or minus here. Why? Because it's a real value. You can't have a negative value for distance. So we get X is equal to the square root of 105 Does 9 go into 105? I think it goes into what, 108? Yeah, 108. So 9 doesn't, 25 doesn't, 49, no. Yeah, so it's just the square root of 105. Not very pleasing answer, right? Not a very pleasing answer, but it's 105. And notice there are units, so I forgot to put my units, and that's a distance, so it'd be in yards. There you go. So that's one where we're solving for a leg. Let's see one where we're solving for the hypotenuse. It's the same basic, should leave that up there. Only it changes on the numbers. It's the same thing. Just in this case, we'll be solving for hypotenuse. So let's find one where we're solving for the hypotenuse. Better have had one. I did not give you a single one solving for the hypotenuse. All right. So we will guess I will put one on there for Thursday's class. I'll just talk about it real briefly. Let's say we had a right triangle and we had 5 and this side was 12 and this side was x. And here's my right angle. So what I don't know is the hypotenuse. All right, so let's see. So that would be 5 squared, that's a squared, plus b squared, that would be 12 squared. And that would be equal to c squared, which in this case was x. So that's 25 plus 1. I am not doing the one that's here. I'm just showing you one where you have to solve for the hypotenuse. 25 and 144 is 169. Ooh, look, perfect square. It's on our list. Take the square root of both sides. So we get x is equal to 13. So when you're solving for the hypotenuse, check it out, we're adding. When we solve for one of the legs, you end up doing a little bit of subtraction. But on both cases, the very last step is to take the square root of both sides. All right, believe it or not, that was a pretty quick review. Yes, it was. So basically, this is your test. I would just have a few less questions what I have on the review sheet. I think I gave you 30 something questions here, 3. So it'll be more like 20 to 25 questions on the real test. So you'll have plenty of time. It is not a calculator test, so this whole thing is done by hand. And if you have any specific questions, make sure that you show up live on Thursday so that you can ask them. Or in the meantime, you could ask me a chat question. That's fine as well too. It just won't be an in-person answer. If you do have any questions, though, send me an email or send me a chat. Be happy to give you the answers. And with that, I'll just sign off, and I will see you guys. Because you guys took the PSAT today, I'm recording this on Tuesday evening. You took the PSAT today, and the other guys didn't have class. Now I'm just the roles are reversed. So the 10th graders are taking the test, so you guys don't get an actual live class for well, technically this is recording for Wednesday. So for Wednesday, have a good day, and I will see you guys. I will see you on the day that we meet back up.